Next, we're going to take a look at the graph of a transformation and write the equation from there. So what I like to do is, first of all, identify the shift. So you look at the new critical point. So in this case, it's 2, 0. So we have a horizontal shift of right 2. And then one thing I like to do is I think about that then as 0, 0. And I think if I go over 1 and square it, I should get 1 if there's no stretch or compression. And in this case, that is on the graph. So I'm thinking, sorry if you can't follow me, I recognize that this parent function is the x squared. And so I'm kind of creating that parent function t-chart in my head. But of course, if it's helpful to you to write it down. And then use those as directions from your critical point. If they match, you don't have any stretch or compression. If they don't, then you figure it out. And we'll see that on the next one. I'll show you how to figure that out. But this one, if I go right 2, I should go up 4 because that matches the directions from my parent function. And in this case, it does. It opens up, so there's no reflection. So the only thing that changed was that shift of right 2. So our new function, grouping that shift with the x and making it opposite, will be x minus 2 quantity squared. Sorry, let me jump back. I'm just seeing the domain and range. I didn't write that down for myself, so I almost forgot it. Looking at the domain of the transformed function, it is an x squared function, so that domain is all real numbers, and that doesn't change even when you transform it. Range, the y value critical point is 0, so we still have y is greater than or equal to 0. Now we'll take a look at our last function. We have our parent function is our absolute value because it's a v. The shifts or the transformations I can pick out right away. We have a shift of up 1 because it adjusted our critical point. And it's opening down, so that was a vertical reflection. So if we set up our parent function values for the absolute value, we would get 2, 1, 0, 1, 2. And now we're going to see what we actually have on our graph. So if I, from my new critical point, go to the right 1, if I have an x value of 1, I'm going down 2. So the negative we know from the vertical reflection, and we can see that it looks like from this y value to this y value that we multiplied by 2. Let's see what happens when we go over 2. Over 2, and it's pretty close to, I obviously didn't graph this quite as accurately as I should have, down 4. So we have that vertical stretch of 2 as well. So when we put that into our equation, the vertical stretch by 2 is multiplication by 2, and it goes outside the asylum. The vertical reflection is multiplication by a negative. And we had up 1, which is also outside the asylum. Domain for our function, it's absolute value. That's all real numbers. That does not change for any of the transformations. And the range, we look at our y value for our critical point. Because of the reflection, we have less than or equal to 1, the y value for our critical point. Here's your U-Try question. Make sure you're coming to class with questions if any of what was said in the video is unclear.